Welcome to EDU World Space.
We'll be looking at a system under tension. Okay, let's say for the structure shown on the board, AB or AC. Okay, the tension in these cables, in either of these cables, should not exceed 1000 IB. I want to know the maximum tension developed in AD as well as the force produced along AE. Now, what we can do is that for each of the members, AB, AC, AE, get the unit vector multiplied by the respective forces. I will take equilibrium by summing him and equating to zero and solve the equation. And of course, we'll consider in when summing the equations, okay, we'll collect lightens based on I, J, K directions so that we're able to solve the equations that will be thrown out. All right, we'll have something that look like, for instance, if we are considering AB, for instance, we know that the unit vector is going to give us, sorry, we consider the unit vector there, say RB, okay? RB is going to give us equal to 10I, 10I minus 15J plus 0K. So it is easy. You can just get it from the diagram there, okay? The diagram that is shown there, you will see it. Now we can look for AB. We can get AB. So AB is actually B minus A, B minus A. If you do that, you are going to have E to be equal to 10I minus 15J minus 30K. Okay, so this is the vector AB. Of course, we need to know the magnitude of AB. To get the magnitude of AB, all we just need to do, in fact, when you solve it, you are going to have it to be 35. The various components there, 10, 15, minus 15, 30. Look for their squares, add the squares and take the root. You have that one. Okay. Then you can now look for what we call your unit vector, as I said earlier on. So for AB, the unit vector is equal to your AB, okay, over the magnitude, which you have already looked for. So when you do that, you're going to have it to be minus, okay, 10I. So no, there's no minus, there's going to give you 10I, okay, 10I over 35, sorry, 10I over 35 minus 15J over 35. Let's write this one well. 15J, okay, minus 30K over 35. Now you can see that's the unit vector. Now you can bring out the position vectors for AC, AD, and AE, okay, and as well as their unit vector, following the same procedure. I'm using the diagrams to do that also to aid you, okay, the diagram to aid you, so that when you now sum all the, of course, I said our force will now be equal to unit vector times and the force that have been given, the tensions in the cables, okay? The force times the unit vector, you'll be able to get the total force. And we'll sum everything together. We'll consider equilibrium and summing everything together and collect lightens based on I, J, K directions. And when you do that, you're going to have equations that look like this: 10 over 35. Okay, 10 over 35. FAB, FAB. Okay, we also have minus 15, yeah, over 35. FAC, AC equals 0. So you can call this equation 1. Call that equation 1. You do the other one. The other one will give you minus 15, okay, over 35. 35 FAB. FAB plus 12.5, 12.5 over 32.5, 32.5 FAD. Okay, minus 10 over 35, minus 10 over 35 FAC. Okay, so you can call equate it to 0 and call this equation 2. You get another one, minus 30 over 35. Okay, FAB. Okay, minus 30 over 32.5 FAD minus 30 over 35 FAC plus FAE equal to 0. Of course, you can call this equation 3. Now, you can just solve equation 1 and get your FAC. Now, we'll consider that FAB, the maximum tension there is 1000 IB. And when we get our result, we'll plug the result of FAC into the other equations, okay, into equation 3, for instance, or into equation 2, you get your FAB into equation 2, you get your answer for FAD, so that you are going to have your answers to the FAC to be equal to 66, 66 664.45 IB, which is equal to 0.66, 0.66. That you get your FAD, which we are actually looking for. The tension, the maximum tension in AD is going to give you 16 27.4 IB, which is equal to 1.6363 KIP. And of course, we'll get that for the force produced along AE to be equal to 2928.9 IB, which is equal to 2.9393 KIP. So that, okay, something like that.